Okay, your note should say 5.5, comes from chapter 5, section 5.
Thank you, Isaac. Absolute value functions. The central question is, what are the similarities and differences between graphing a quadratic exponential, which we reviewed exponentials last time, right, and the absolute value functions? That's fine. So there's a reason why we spent the whole term pretty much on quadratic functions. Because all of the other families of functions, you can see those in just a sec. All the other families of functions follow the same properties that the quadratic does. So to start off, we list a few of the families of functions. Actually, let's do it this way. Do it that way. Okay, so this one you learned in 9th grade and we reviewed last time. Y equals A times B raised to the x minus h plus k. What function is that? Exponential, because it's an exponent. The x is in the exponent position. This one we've been working on all year pretty much. There's the second one. Y equals A times x minus h all squared plus k. What function is that? Quadratic. Because it has an exponent of 2. Now, we used to teach all the functions in secondary 2, but now, because there's too much in secondary 2, we gave some of it to secondary 3. So you'll actually see the rest of these functions, except for the one we're learning today. All the other ones you're going to see here are going to be next year, but the same properties apply. So this one is y equals to looks exactly like the quadratic, except for that in your bag, where I'm going to take a little bit off this. So what's different about it? It's got a cube, so it's the cubic function. We have the quadratic function and the cubic function. Write it down if you haven't. Next, we have, that function's called square root function. You're correct. You'll be able to learn that one next year. But it still has the same, these are called transformations where we shift the graph from side to side and up and down. We have flip graphs and stretch and compress graphs. They all follow the same properties. What do you think this one's called? Cube what? Cube root, because they all have a cube root in it. Makes sense, right? Notice, so all of them have an A, an H, and a K in the same position? Yes, the A is always multiplying out front. The H is always inside of the function. The exponential has the H inside of the exponent. Quadratic has the H inside of what's being squared. The cubic has the H inside of what's being cubed. The H is inside of the function of the square root. And we're inside of the cube root. And the one we're learning today, I can find the exit button, is the absolute value. A times the absolute value of x minus h plus k. Okay, we need to make sure you have the canvas. Watch the video. Thank you. It's cross screen. Alright, so no matter what the function is, because we're talking about quadratics, you should be able to tell me that something being added or subtracted in the h position inside of the function we did to the graph. Horizontal shift. Excellent. What was something being added or subtracted outside the graph too? Vertical shift. So even though we've never seen a cubic function and no idea what that looks like, I do know that if we're adding inside the function, it's going to shift horizontally. Adding the function is going to shift vertically. Same with what we're doing today. Horizontal shift, vertical shift. And what's that saying we have? Opposite, same. Same here. And we can do this on all of them. That would be annoying because it's all the same. All 6 of these. And we can train functions the same way, which we'll learn at the end of next year. Alright, if you remember everything with the A, You can tell me what happens when A is less than 0. Raise your hand, I'll show it out. Vivian? Vertical flip. Okay, someone else. What happens when A when A is greater than 1? Anne-Marie? That one, good one. Because your stretch, because your rise is more than your run, like 3/2, and the up 3 and the out 2. So your rise is more than your run. So that's it. Vertical stretch. Okay. Since y'all know me so well, I'm going to give you the answer. Like Jeopardy, tell me the question. So go here. Then what can I write first? Well, 0. No. Okay. Okay, so that's A is 0, or A's absolute value of A is between 0 and 1. So it could be a fraction, it could be a decimal. But don't be deceived by all fractions. Can some fractions be greater than 1? Yeah, so just because it's a fraction doesn't mean it's vertical progression. Okay, so, right. We're going to find this absolute value and see what happens. We're just going to go through a couple problems. It's pretty straightforward. So, our parent function, we're going to graph the parent function. It's the most basic function without any bells and whistles on it. Y equals absolute value of x. Make sure your absolute value symbols are nice, long, and tall, so you don't think it looks like 1x1. Okay, well, let's see if it's wrong. Is there anything being added or subtracted inside? Yes. Anything after? So we're going to say opposite, say what point we come up with. 0. 0. Okay, let's put graph looks like it. We're going to shut calculators, right? Paper, oops. I don't want that. How did that come up? I don't want this. No. Okay, when we watch, there's the calculator. Oh no, did I close the whole thing? Just shoot. Putting down this graph here. Okay. Alright, I did close it out. So this is what we're trying to graph. The parent function y equals absolute value x. So we're a calculator. So you need a calculator? You can wait. Or did you can wait or use the model because you didn't take that shit? Okay, that's why. Okay, I'm going to calculate to put my question mark to give the calculator a function. Y equals. Now, some of you are calculating because it's frustrated. Now, where in the world is the absolute value sign? So let's erase what's there so we can learn where to find it. So that's clear. Nope, if you look at all the buttons, it's not actually here. So what we need to do is go to math. The math button is underneath your grade alpha button. It's not listed, so we're going to go right to number, num, and it's the first one on the list. What's the abbreviation for it? Abs. Okay, so that's the value of your calculator. Go to math, and then we arrow over to num. And then we select abs. Second 0, I've never done that before. So over here, second. That is fast. I've never done that before. Thank you. Second 0. They must have ways to different programs. Alright, and then just put your x's as the absolute value. Okay, now make sure our graph is standard. Everyone's on the same window. Negative and positive. Let's go to zoom. Which one's your standard one? 6. Do standard. Let me pay attention to what shape the graph does. And say V, which is why it was a quadratic, and the graph knows it kept saying, make sure it's curved by the vertex. Because the V graph is something different. Absolute value values, that's the V. Absolute value graphs are V's. Okay? Since we know the vertex is at 0, 0, my math calculator. There it is. Since we know because of opposite same and what is the graph, let's get a table of values because we're going to plot two different graphs on the same table of values. When we do table of values now, we have a function with a vertex. We put the vertex in the middle. And the vertex is what gets shifted left and right, horizontal shifts and vertical shifts. So basically, I can use down in my hand. So 0, 0, I need a couple smaller. So there's a couple smaller than 0. -1, -2, now I need a couple bigger. 1 and 2. We can let our calculator do that for us. How do we get those? Table. Second is the graph button. Second graph, which gives us, come on. Doesn't like it today. Second graph. There we go. Now we need from -2 to +2. Okay, Andy, will you tell me the y value starting at when x is -2? Right, it shows the positive because the absolute value is positive except for 0. Okay, quickly, let's draw a graph. 2, 3, 4, take out 2 positive, -5. And then we have to put a second graph on this. And plot those points. So when you connect the points, you should make sure that both arms are linear. The A in this case is exactly like slope. With quadratic, it's similar to slope, but the slope is always changing because the arms are curved. That's the value. Both arms are linear. One arm has a negative slope, the other arm has a positive slope. So to connect them, our first arm has a negative slope, and our second arm has a positive slope. And the reason the slope is a 1 is because A is 1. Okay, yeah, that's good. Okay, next you have we're going to graph this on the same graph. One more problem. Y equals 2, absolute value, x plus, x plus 3 minus 1. That's the last one on the outside. Who can tell me the vertex of this A? I'm going to really hand on this one. Opposite, same, right? That was the vertex. X blue, or A3, same, opposite, same. Do opposite, opposite. There you go. A3 -1. So, in our chart, vertex in the middle, -3 -1. Need a couple smaller and a couple bigger. So that's what's a couple smaller than -3. Others are bigger. It's smaller. -4 and -5. So, you can do it by hand, or you can come give it to your calculator. Go back to y equals. Above the delete button, it says INS. That means insert. If you put your blinking cursor on the first bar of the absolute value and go second delete, which is the insert button, you can type in 2 and insert it in. So you don't have to delete everything, you can just insert it. And then I get a +3 on the inside, and then a minus, what is it, -1 on the outside. And then you go to the second table. Okay, and I use my arrows so I can see all the way to x is negative 5. Okay, so do you have the y values for me when x is negative 5? That's interesting. Look at these numbers. 3, 1, negative 1. What's the difference between each of those? 2. And negative 1 to 1 to 3, what's the difference between them? 2. Any idea why? Because the slope is 2. And one of the arms has to be, okay, one of the arms has to be negative and one has to be positive. So, on one half, going down with the difference of 2, on the other side is adding 2. So plot those. Negative 5, 1, 2, 3. Since the slope is positive, it should look steeper to us. Negative 1, 1. Negative 3. Oops, I need a negative 1 down there. Negative 1. Negative 2, 1. 1, 2, 3. Does it look like a vertical stretch to this get skinnier? Does my blue bee get skinnier than the purple bee? Yes or no? Yes. It did. Because our multiplier was greater than 1 when the vertical stretch. And when you stretch something, it gets skinnier. Okay, the homework today is going to be on Excel. And if you remember, that we need accounts. We're going to computer lab on stage 4, but we never actually use it because I hate going to computer lab every day. Now we have our own computer lab, Chromebooks in the room. So I'm going to give you a number. And what we're going to do is log on. When you log on, instead of picking one of the pictures you're at, you need to take a picture of yourself so that it's easier to find yourself. And then your username is up here. In case you forget, I'll you use this in English, so you're probably already familiar with it. And then I want you to log into mathexcelcourseschools.com to make sure you can log in and to find the assignment. The assignment is 55x the value, your username is your email address, the password is something you wrote yourself. So if you forgot it, you can have to email to your email address. So I'm going to forgot my password link. So I'm going to give you a number, and I need you to write this number down and remember it.